Okay, let us see how we handle this one. This one we are going to borrow some ideas in differential equations. For non-exactly is first order, non-exactly is where we use the idea of integrating factor. We saw that as a full topic. The lessons are there. You can go for the playlists. Then you go down, you will see there differential equations. It was handled as a whole. And now this one, we're just going to use part of that for especially first order non-exactly is. So let us go through the question. The gradient of a tangent at a point of the curve at any point of a curve is given. So this is the gradient function of the tangent to that curve. If the curve passes through a point this, find the equation of the curve. Now, if they are telling us that the gradient of the tangent is this, it means that remember to get the gradient of the tangent, we differentiate the curve. So meaning this one is a gradient function. So in our solution here is going to be very easy. Because this is the gradient of the function, it means that now minus the y, the x is equal to x minus 2y, the whole over x. Because this is the gradient of the curve, and that our gradient function is given by this if you have the variables of x and y. Now, the hint we are using here, the gradient function is given by this. Now, because this is the gradient of the function, it means that now our task is to integrate this. Remember, we differentiate the curve to get the gradient of the curve. So the gradient function is this. Now, we know that the integrating factor for first order non-exactly is given by, some people call it if, or me I'm calling it r. We given integrate e power p, the whole of this dx. Now, here the idea is very easy. Sorry, this e is not in that order. This r is given by e. This r is given by e integral of p dx. How do you get a p? The p is always, if you have the equation in this form, that's how we get our p in that order. We arrange this in this form. So now I take everything this side because here I need a function of y. So now you see the function of y is this side, so I take this one the other side. So from there I have this as y dx now plus 2 over x y equaling to x. Now you can see, just taking this side. Now you see it is in this form. So that this one is going to be first order. Why do you call them first order? Because you see this one is order 1. Non-exact because you cannot see what you differentiated to get the left hand side. So there, if I compare with now, if I compare with the y, okay, if here I'm to compare with I'm going to compare with my y dx plus py equaling to q. From here, you can able see that our my q is this, then always our p is the coefficient of 1. So now, you see if I compare here, my p is going to be 2 over x, the coefficient of y. We only compare if this coefficient is 1. You see it's already 1. Now, from here, to make it, because this is the first order non-exact, our interest is to make it exact. We make it exact by multiplying through by the integrating factor. But how do you get that integrating factor? Our integrating factor is given by r equaling to exponential integral of p dx. That's why I was interested in this. So now, to get my integrating factor, I'll say this is given by integral, it's given by e integral of p dx. Now I have my p, from here is what my p is this. So now, this is going to be now e, now integral of 2 over x dx. Now take this out, this is going to be equal to e to natural log of x. On the internet, we will take this out and integrate this. So remember, when we said we will have integral of 1 over x, the x is going to be natural log of x. But remember, I have a constant here, which I'm taking out. That's why I have 2 here. Now, apply properties of logarithms. This one is going to be here. This one will be the same as e power natural log of x power 2. When I bring this here, get this. Now remember properties of indices. But now our integrating factor is going to be x squared. How do we get x squared? Use properties of logarithms. E natural log of a. This one is giving us a. So that's what I have applied here. So this and this is giving me this. So we saw this is log base e, and this is e. So always this one is going to be giving us this. That's why I'm adding that there. So using this property here. E natural log of a is equal to just this. If the base is equal to this, then this is equal to that, as long as this is coefficient 1. So e, this is the limit of now the whole of this. So the whole of this will be equal to just this there. Now we have got our integrating factor. Now after getting our integrating factor, which I'm okay, let me call it r. If we get our integrating factor, so therefore my r is equal to x squared, the integrating factor. Now after getting the integrating factor, this integrating factor, if you multiply it through this equation, now we make it exact. So now if I make it exact, it means that now I multiply through out with r. I multiply here by r. So multiply through by r. Multiply through by r. Here, so there now r dy dx, then plus r times 2 over x y equal to rx. So now my r is this, so this will be x squared y dx plus, now this will be, this is x squared times x, I'll be adding 2xy equaling to now x cubed. So now it's now this one is now we have, but now it's exact. Why do you call it exact? Because you can see what you differentiated, you get the left hand side. It's that now it's the same as dx of this. Now I differentiated x squared and y. If you fix this and differentiate this, you get this. Then fix y, differentiate this, you get that. So that's why I'm able to compress it in that order. Or what some people do, immediately after getting the integrating factor, they come and say, you get r times y. So you can skip always this step. And it just say, get r times y. Then equate it to r times q. So that's why I'm getting r times the cube. Yes, that my cube is x, which is x cubed. So some people from here, they just say you get the x of r y equaling to r cubed. So if you don't want this, this is now, this shows understanding if you do this. Because you can maybe show someone that you know what you differentiated. So when I differentiate this, I get this. But if you just come to this step here, you get always r times y, then you get to r times cube. Where your cube is what you got here. I think you start from there, your cube is that. So your cube is x when you compare there. Anyway, so here we separate variables. So I have the x squared y equaling to x cubed dx. Then after there, here we are just separating variables. Then after we integrate both sides. Then I integrate both sides. We get x squared y equaling to x power 4 over 4. How to integrate? You increase the power by 1. You increase this power by 1 divided by the new power. That's why we have that. Then plus a constant of integration. Now, this is the equation of the curve. Remember, we have a constant of integration, so remove this constant of integration. How? Told us that this curve is passing through this point, meaning that this point is located on this. So you say at 2, 4, because this curve is passing through this point, start from here, this is our x is 2, our y is 4. Putting them here, we have now 2 squared minus 4 equaling to 2 power 4 out over 4, then plus c. And so this is going to be 16. So from there, it's 16, 4 times 4 equaling to 16 divided by that, this is 4 plus c. Like that now, my c is going to be, when I take this side, I get a 12. So now I have the constant, so therefore, I can come here and maybe write my equation as x squared y equaling to x power 4 over 4, then plus my c. So you can see my c is going to be a 12. If you don't want this, you can maybe multiply it by 4, which is 4 x squared y equaling to x power 4, then plus 48. That's our as simple as that. So this was just application of the easy. Always whenever they give you a gradient function, don't forget that the gradient function is given by this. So another thing you had to know that E, natural log of A, as long as this is coefficient 1, is always according to this, as you see there. Just apply there. Then after you get the integrating factor times the y, then you differentiate it, and then you equate it to r times q. Q is what is always inside. So if you want, always also you need to know how to integrate 1 over x. So after that, members, now you can go through, because we covered this in details. You can go in the playlist and then you list the ease. Okay, that's it, members. Don't forget to subscribe to the channel. I wish you well. See you.